Hi everyone, welcome back to the channel. Today, we're diving into the fascinating journey of how atomic models have evolved over time. It's a story of brilliant minds, groundbreaking experiments, and the constant push to uncover the secrets of the atom. Let's explore the models that shaped our understanding of the atomic world, and how science moved forward step by step. 1. Dalton's model, the early atomic idea. We start in the early 1800s with John Dalton, who introduced the idea of the atom as a solid, indivisible sphere, kind of like a tiny, unbreakable ball. Dalton's model helped explain the law of conservation of mass in chemical reactions. But it had a big limitation. It couldn't explain the internal structure of atoms or their electrical properties. Think of Dalton's atoms as the simplest concept of what matter is, made of just small, hard particles. But science would soon reveal that atoms were far more complex. 2. Thomson's raisin pudding model. Fast forward to the late 19th century, when J.J. Thomson discovered the electron through his famous cathode ray experiment. He proposed what's known as the raisin pudding model. In this model, electrons, the negatively charged particles, are embedded within a positively charged material, like raisins in a pudding. This explained why atoms are electrically neutral overall. However, Thomson's model had a flaw. It didn't account for the existence of a nucleus or explain the stability of atoms. 3. Rutherford's solar system model. In 1911, Ernest Rutherford changed the game with his alpha particle scattering experiment. He discovered that atoms have a small, dense, positively charged nucleus at their center. Rutherford proposed a model where electrons orbit the nucleus, much like planets orbit the sun. But there was a problem according to classical physics. Orbiting electrons should lose energy and spiral into the nucleus. That means the atom would collapse, but we know that doesn't happen. 4. Bohr's quantum leap. Enter Niels Bohr in 1913. Bohr improved Rutherford's model by introducing the quantum hypothesis. He proposed that electrons could only exist in specific energy levels or orbits. When electrons jump between these orbits, they absorb or emit energy in the form of light. This explained the spectra of hydrogen atoms beautifully. But even Bohr's model had limitations. It couldn't fully explain atoms with more than one electron. 5. Modern quantum mechanics model. Finally, in the 1920s, we arrived at the modern atomic model, thanks to the development of quantum mechanics. This model introduced the idea of orbitals, regions in space, where electrons are most likely to be found. One key principle here is the uncertainty principle by Werner Heisenberg, which tells us we can't simultaneously know the exact position and momentum of an electron. This quantum mechanics model successfully explains the properties of atoms, including the complex spectra of multi-electron atoms. Let's come to conclusion of today's story. The journey of atomic models shows us how science evolves, each step built on the work of previous scientists, overcoming limitations with new experiments and theories. It's also a reminder that scientific knowledge isn't set in stone. It's a process of continuous revision and development that brings us closer to understanding the universe. Thanks for watching. If you found this video helpful, don't forget to like, subscribe, and share it with your fellow science enthusiasts. Until next time, keep exploring and stay curious.